Alright, so this is going to be just for the very last 2 slides on the isosceles triangle notes. So I did the first 6 slides in the first video, and now this one involves solving for x, so I wanted to do these separately by themselves. Now, if you can remember that all the angles in a triangle add up to 180 degrees, and then we also remember how isosceles triangles work, then you should be fine with these. Just don't rush through them, think through them, and we're going to take them step by step. So the first thing I want to notice here is that we have to find the measure of each angle. So we want the measure of A, B, and C, but right now we can't find the measure of any of them. A is totally blank, it has nothing going on there, and C and B I have quantities, but I don't know what x is. So I notice that my isosceles triangle marks are here. So that means if these 2 sides are the same, that means that these 2 angles have to be the same. So I can set them equal to each other. So I'm going to have 4x plus 10 equals 6x minus 1. And now I have to solve this for x. So here's my equal sign, and remember whatever we do to one side we have to do to the other side. So the first thing I'm going to do is subtract 4x from both sides. So I have 10 equals 2x minus 1. Then I'll add 1 to both sides. So I get 11 equals 2x. And then I'll divide both sides by 2. And I'm running out of room here, so I end up having, let's see, 5.5 for x. Now that's just a value, that's just an x value. That's not representative of any angle. I'm not going to say that A equals 5.5 or B or C. None of them equal 5.5. 5.5 is simply the value of x. So what I need to do now is I need to plug it in. So if I plug it into C, I'll have 6 times 5.5 minus 1, and that gives me 32 degrees for angle C. And then B should also be 32 degrees because it's an isosceles triangle, so we drew these arrows in to show that they should be the same. And when you take this, 4 times 5.5 plus 10, you do get 32 degrees. So both C and B are 32 degrees, just like we would expect in an isosceles triangle. And now finally, I have to find A. Now remember, there was nothing here at A, so there's nothing I can plug x into. There's no quantity here, so I just have to treat this like it's any other triangle. If I know 2 angles, to get the third angle, I just subtract from 180. So 180 minus 32 gives me 116, and that's going to be my measure of A. So if you see the isosceles triangle marks, the first thing I would do is draw in those arrows so I know that those 2 are the same. Solve for x, and again, take your time, there's no rush, think it through, and then always plug your x back in because x is not an angle measure, x just is a number that you're going to plug back in to find the angle measure. And now the last one also deals with an isosceles triangle, but you'll see it's just a bit different. There we go. So I see my isosceles triangle marks again. However, in this example, here's my blank space. I don't have the x quantity down here like I did before. So now what I have to do is, if this side is 6x minus 7, then this side is 6x minus 7. I can fill that in. And now I have all 3 angles in a triangle, so I'm going to add all 3 of these up to equal 180. So 6x minus 7 plus 6x minus 7 plus 4x plus 2 equals 180. A mistake that students will sometimes make is they'll forget to write this one in, and they'll just take those 2 and add them up to equal 180. But that's not true. Remember, you need all 3 to equal 180. So now, here's my equal sign, and remember, whatever you do to one side, you have to do to the other. So all my x's are on one side, so I'm just going to add them together. So 6 plus 4 is 16x. And then negative 7 plus 2 is negative 12. And now I can solve this. So I'll add 12 to both sides, and I get 16x is 192. And again, I ran out of room, so I'll move it up here. Now divide both sides by 16, and I get that x is 12. And again, that 12 is just a number. It's not an angle measure. So I'm not going to put it up here for our s or t. I have to plug back in. So I have 6x minus 7 here. So 6 times 12 minus 7 gives me 65 degrees. So that's going to be for s and r, because remember they're both equal to 6x minus 7, so I could plug it in over here as well, but that's 65. And then up here, 4 times 12 plus 2 gives me 50. So that's going to be 50 degrees. Although I see on my notes I used green for that, so I'm going to erase this and just rewrite it in green so that you can see the difference. Maybe. There we go. Sorry for that. So 4 times 12 plus 2 equals 50 degrees. So t is 50 degrees. Okay? So when you see two quantities in an isosceles triangle, don't just automatically set them equal. Sometimes you'll set them equal, but sometimes you'll duplicate one of them and then add all three up to 180. So these last two examples are the two different types of isosceles triangles you'll see when you have to solve for x. Now if you're having any trouble with this, please ask me. I can explain it to you over and over. Or if you want some extra practice, isosceles practice number 2 in the crate is some really good practice for you. Again, and if you have any questions or you want me to give you some more examples, please don't hesitate to ask.